Hello children, welcome back. In the previous lecture, we understood about the galvanometer and how to convert the galvanometer into ammeter as well as a voltmeter. We done a few problems. Let us continue the problem solving, and here we have the two more problems. Let us try to solve them. The first problem, let us look at. So a galvanometer has a coil resistance of 100 ohm. Therefore, what they have given, the first solution I am writing, the galvanometer resistance is given as 100 ohms, and it gives a full deflection for 30 milliamperes current. That means indirectly they have given us the value of Ig, which is nothing but 30 milliamperes. And if it is has to be work as a voltmeter of 30 volt range, what is the resistance to be added? We know very well what is the resistance in series that has to be added, G times of n minus 1. What is the N? V divided by Vg minus 1. They have given the V, that is nothing but 30 volt range. And what is the Vg? Vg can be calculated from this information. Vg is nothing but Ig into capital G. So Ig is how much? 30 milliamperes, and capital G is given as 100, which will give you 3 volt. Then let us substitute back. What is the series resistance now? R will be equal to G value is 100 multiplied by the V is nothing but they have given us in 30 volt divided by 3 minus 1. So 100 times of 9. 10 minus 1, 9. So which will give you 900. 10 minus 1, 9. So 900 ohms. This is the series resistance that has to be connected across it. This is the solution of the first problem. Let us look at the second problem. A millivoltmeter. Let us look at that. So second problem. So what they have given, let us see. A millivoltmeter of 25 millivolt range. The range they have given 25 millivolt. It should be converted into voltmeter of 25 amperes range. What is the value of necessary shunt resistance? Now you tell me what is the shunt resistance formula? We know G divided by I by Ig minus 1. Then this can be also written as Ig into capital G divided by I minus Ig. Am I right? So this value is nothing but what? Just now we have seen Vg divided by I minus Ig. So here this Vg value they have given as a 25 millivolt. So what I can write? 25 millivolt divided by what is the current range? That is nothing but 25 ampere. And here we ignore the Ig value since the Ig value is very small. How can I say it is very small? If I want to, so this millivolt range is how much? 25 millivolt. And see, the millivolt range is nothing but Ig into capital G, which is nothing but 25 millivolt. See, the value of G must be always greater than the 10 or 15 it will be. So Ig value will be very small. It is like a milliamperes, which is very small compared to 25 amperes. Therefore, we will ignore this Ig. Hence, what we can write? 25 millivolt divided by 25 amperes, which is nothing but 1. This is going to be 1. This is nothing but amperes. So what we are going to get? 1 milli ohms. So 0.01 into 10 to the power of minus 3 ohms, which is nothing but 0.01 ohms. 0.1 by 100, 0.001 ohms. So it is going to be given as a 0.001 ohms. This is going to be the resistance that has to be connected. And finally, we will solve one more problem. With that, the topic will be over. So since the galvanometer current is very small, it's going to be like a very small. I have ignored that term here. Here we have the last problem from this concept. With that, the topic will be over. Yeah, so here is a concept like this. A galvanometer of resistance ohms is connected to a battery of 3 volt Well, see this last problem. Here we have a galvanometer having the resistance equals to 50 ohms. So capital G is given as a 50 ohms. It is connected in series with the resistance of 2950 ohms and across the cell of 3 volt. Therefore, what is the series resistance? 2950 ohms. Now, what is going to be the effective resistance? Effective resistance nothing but sum of the both because they are in series. Total how much? 3000 ohms. Now, what is the voltage across it? 3 volt. Hence, what is the current going through it? I equals to V by R. So it's going to be nothing but 10 to the power of minus 3 amperes, 1 milliampere. This is the current flowing through it. Now, this 1 milliampere is sufficient to have a full deflection of 30 divisions. Right? So what I can write now? 1 milliampere can produce 30 divisions of full deflection. Now they are asking to find out how much resistance I have to add so that the deflection will be decreased to 20 divisions. Therefore, 20 divisions will require less current only, right? 1 milliampere can produce 30 divisions. Now, how much current can produce 20 divisions? That can be found like this. 20 by 30 multiplied by 1 milliampere. So, this will gives you 2 by 3 milliamperes. So, what I can say now, 2 by 3 milliamperes is large enough to produce a full scale deflection of 20 divisions. Full scale deflection of 20 divisions. Now, so what we have to find out? We have to find out the what is the additional resistance I have to add. Therefore, I can write also like this. 2 by 3 milliamperes. I equals to V by R only, right? What is the V? 3 volt. What is the V? 3 volt. That will not be changes. 3 volt divided by the resistance must be R. The total effective resistance. Here, this I have calculated with respect to effective resistance, right? So here also it will be effective resistance. How I have proceeded here? The same way I am proceeding here. Now from here, what is going to be the effective resistance now? R effective is nothing but 9 by 2. So it's 10 power minus 3. It will go to the numerator as a 10 power 3. Right? So now this is going to be equals to what? 4.5 into 1000. So 4000. So 4 by 00. This is going to be the total resistance, effective resistance. Now to this, already the galvanometer is connected. How much resistance? 50 ohms. Therefore, the resistance to be connected is nothing but what? R effective minus capital G. And that value is nothing but what? 4500 minus 50 is equals to 4450 ohms. This is going to be the series resistance that has to be connected. You understood? Shall I repeat the question? A galvanometer has a resistance of 50 ohm and it has a resistance of, the series resistance is 2950. What is the effective resistance now? 3000 ohms. With that, what is going to be the current? 1 milliampere. Now, the 1 milliampere is large enough to have a 30 full deflection. Now, if I want to produce the 20 divisions, how much current I require? 2 by 3 milliampere. Now this current has to be drawn from the same 3 volt battery. Therefore, what I have written? 2 by 3 millivolt must be equals to V divided by R effective. So R effective is nothing but this 10 power minus 3 that I have sent to that side. So that it becomes 9 by 2 into 10 power 3, which is given as a 4.5 into 10,000, which is equals to 4500 ohms. So this effective resistance is nothing but a combination of galvanometer resistance addition to the extra resistance. That is nothing but, let me call it as an R prime, because here I have called it as an R. Therefore R prime will be equals to what? R effective minus G. R effective here I have found as a 4500 minus 50. So 4450 ohms. And that's the end of the concept of galvanometer and conversion of galvanometer into ammeter and voltmeter. And that's the end of magnetic effects of current concepts. Now hereafter we will go for another concept called magnetism. So first I will cover the bar magnets and the various effects shown by the bar magnets and the related things. And finally I will go with the magnetic materials. And finally one more thing, that is terrestrial magnetism. With that, the total moving charges and magnetism will be over. Thank you.